All right, so we're here with Jon, CEO of Pambili, and Ben as well, CEO of Kavango Resource. And I think to start things off, before we head over to Golden Valley, we should ask you, Jon, kind of first, what brought you to Zimbabwe to do business, and Ben can answer the same question afterwards.
Well, as you probably tell from my accent, I'm originally from this part of the world, and I still have family here, and I've always wanted to get back here and do some business, and the opportunity came when I became chief executive of Pambili, and the opportunity arose to invest in the Happy Valley mine, which I grabbed with both hands, and that was the start of the journey. And through that initial project, I met Ben. I actually had a conference in London, and it turns out that we had a couple of people in common that we knew, including Steve, who we'll meet later, yeah, that was the beginning of the journey. And Kavango is now a big shareholder of Pambili, and I'll hand over to Ben.
So, as Jon mentioned, Steve, I've known Steve for about 5 years. He's an exploration geologist. He spent 40 years, his entire career, around Southern Africa. He's a very good friend of mine, and he'd been trying to get me to come over to Zimbabwe for a very long time to look at the investment potential here. Well, 2 years ago, he finally managed to persuade me to get on a plane to come to Bulawayo, and I spent an incredible 5 days here. He picked me up from Bulawayo Airport, took me straight out into the field, and I fell in love with the place. I saw enormous potential in this country, both from a technical, geological perspective, but also from a commercial perspective as well. We'll get a chance over the next few days to talk a bit more about that and show what we've been building with Kavango. But it's a very, very exciting jurisdiction to be in, and I absolutely love being here.
And then, Jon, I mean, if you just kind of characterize the broad-based strategy, because now we're talking about Pambili first. So right. What's your strategy to create value for shareholders, kind of broad, high level, and also to engage with stakeholders here locally, and so everyone gets value from your business?
Right. So you'll find over the next few days that the scale of projects in Zimbabwe is relatively small in world standards, but we're aiming to achieve 20,000 ounces a year, and we'll do that through probably two local centres. So Golden Valley will be the first hub. We'll get the 10,000 ounces a year from processing our own ore, but also processing ore from third parties, and also joint ventures, all within trucking distance of the central hub. At the same time, we're also looking at other opportunities in similar greenstone belts further afield, where we'd find another cornerstone mine, if you like, which will become a central hub, and we'll replicate that, also aiming to do another 10,000 ounces a year, so ultimately achieving that 20,000 ounce target.
Right. And you're a small company now. Just to get this out of the way first, what's your current market cap approximately?
We're sitting at around 2 million Canadian, just over 2 million Canadian, yeah. Which is relatively small. But the point is, we do have a listing that does allow us to, in a way, have currency to do deals, and that's what we're really aiming at. The Golden Valley acquisition was done on pretty much an all-share deal, yeah. Which means that any money we raise is going into the ground rather than going to vendors. And I think that's also attractive for incoming investors. They're seeing the money is actually going to develop the assets, and that's our gameplay going forward.
Right, and then kind of the high-level balance sheet, your approximate cash / working capital. Now you're a 2 million CAD company, 1.5 million CAD. What kind of cash do you have currently? You have a raise, we know, we'll get to that later, but what kind of cash, and do you have any liabilities on the balance sheet currently?
We have a few liabilities, obviously. A lot of them relate to some of our legacy stuff in Canada, which we're disposing of. That will be out of the way by the end of the year. But locally, we have very little in terms of debt. We are trying to fund things through limited gold sales we've had to date, and we have raised money locally. Obviously, we've converted a loan from Kavango into equity. That was very instrumental in us getting us off the ground. We've also just raised some money recently in Zim through debt. So we're in good shape for the next couple of months. And as you say, we're looking to raise more money, hopefully on the back of another acquisition, but certainly on some production and drilling targets from Golden Valley. Yeah,
and just to clarify, I mean, of course, Kavango, you're a strategic partner of Pambili, and it allows Pambili to punch above its weight, of course, in relation to the size of the company. But can you kind of explain the nature of the partnership? You've funded Pambili sequentially here, but what's the nature of the on-ground kind of operatorship and the partnership in that regard?
So because Kavango's invested so much locally, building up our team, our operational team, our exploration team, and increasingly our mining team, what we're able to provide Pambili beyond access to finance through our network and through our investors, we've provided a ready-made solution for Pambili to grow its business business in terms of having the team and the people already recruited on the ground. We've also identified a pipeline of projects. One of the things about Zimbabwe, the opportunity here is absolutely enormous. I've tried to articulate this and describe this to investors, just how big the opportunity in this country is. It's far more than one company could handle. It's probably far more than dozens of companies can handle. So where Kavango is focusing its efforts on one greenstone belt, Pambili is focusing on another greenstone belt that's 70 kilometres away from us. So from Kavango's perspective, what this provides is an obvious way for us to leverage all of the work that we put in on the ground with the team that we've recruited. The people we have here are doing fantastic work. To enable a company like Pambili, we put it through its incubation process. $2 million Canadian dollar market cap at the moment is tiny, but by following this production strategy, getting up to that 20,000 ounce a year target, which we believe is achievable over the next couple of years, it will obviously create for Kavango what we hope will be a valuable asset on our balance sheet as well, while we're incubating another listed PLC, which again is also very important for Zimbabwe. The more listed companies that come here and actively invest and make a success of their work, the better that is for everybody. We're hoping to help create a tide that all ships can rise on.
Excellent, and that's this place, right? The plans for this place is to have a hub where you can help new groups get set up in Zimbabwe and work. So that's part of Kavango's strategy, which we'll get back to in a little bit.
Absolutely. So the whole operation that we have here, as you take a tour around, we've set this up primarily for Kavango, to get Kavango off the ground. Pambili has slotted into this turnkey solution that we're building. But yes, in future, we're creating a gateway to enable other listed PLCs to have that entry point, that safe, reliable entry point into Zimbabwe, so that they can establish their operations and start to grow their businesses. I can't emphasize enough how big the opportunity is here for more listed PLCs to come and seize this opportunity, grow their businesses and unlock this nation's enormous mineral potential.
Right, and then just to crystallize for people, kind of Kavango, I mean, you're a 20 to 30 million US market cap company, and you're backed by a group called Pure Bond, and you also have Peter Winterby with you. So maybe you can just contextualize your ability to actually get funding, because that's very unique for you guys in a risk-perceived jurisdiction.
Absolutely. So we're actually a 30 million US company. Our market cap's about 22 million pounds. We've been incredibly fortunate to have the backing of the Consagra family. They're British billionaires who have a privately held company that's got business interests across Africa. They have a very high appetite for risk. They've taken, sort of great steps to support our business, which really does put us in a unique position. We are extremely well financed. They own 58% of the company at the moment. We're also able to draw from the support, as you rightly say, of Peter Winterby. Peter's had a phenomenal career, with a successful career in mining in jurisdictions that a lot of the rest of the world, it might seem a little bit too hot to move into. Peter's a contrarian. He's had fantastic success most recently with Moxico Resources, where he took an initial $100,000 investment into the Mimbula copper asset in Zambia back in 2015, at a time when no one wanted to invest in Zambia and no one wanted to invest in copper. And he's taken that up to a company that's privately owned and is worth over £1 billion today. So we're very, very fortunate to have someone of Peter's calibre and his with his sort of knowledge of the industry to help us drive our business forward commercially. So yeah, we are in a very, very strong position for a company of our size, being able to draw from not only the financial support, but that level of experience as well.
Hi there, my name's Steve Smith and I'm a geologist and technical consultant for Pambili Resources. And I've been working here in Zimbabwe for about 15 years, collecting information and looking at various deposits. Just a brief discussion on the mineral endowment of Zimbabwe. Here's a geology map of the country, and you can see the 22 greenstone belts here highlighted, and what's actually on these little lines are the names of the gold mines. There's something like 6,000 registered mines in Zimbabwe. It's very well endowed. It's got gold, it's got platinum and chrome in the Great Dyke, it's got lithium, it's got tungsten, it's got coal bed methane, it's got coal, it's a very incredibly well endowed country. Not many people know this, but back in 1980, Zimbabwe was producing more gold than Australia. But subsequent to that, obviously Australia's taken off with the open pit boom, and the gold mining industry in Zimbabwe is more or less stagnated. In the 15 years I've been here, we've collected a huge amount of information, historical and digital, and in a few minutes I'll take you through and look at the data room where we store some of this information. Okay, we've just come across to the data room. We've literally just finished constructing, and we've only just moved all the information in here. You can see by looking around, there's an awful lot of plans, drawers full of geophysical information, old aerial photographs. We have files on many different mines and prospects from old data. It's all handwritten stuff or typed stuff. It's probably the only data like this in existence. Stuff that's been collected from people's garages, from old mine offices that have fallen into disrepair. I found plans with rats' nests in them, wasp nests, and we've now scanned all the plans. And we've still got a big job to do to digitise it all. To give you some example, we've even got the entire sampling. There's a drawer for the rest of these files for one of the mines, which allows us to put that together in 3 dimensions. And obviously that sort of information will give you a good competitive advantage and allow you to kickstart your exploration program. And all this information is available to Pambili and to Kavango, which a lot of it is unique. It no longer exists. It's the original stuff that we've managed to save and put together.
And before we head out, I mean, how far is it a drive to Golden Valley from here? Because now we're in Bulawayo, the kind of the center here where you operate out of. What's the drive and what's the distance?
We're looking at less than 15 kilometers. We should be there in just over half an hour.
All right, so we're here at a vantage point over at the Golden Valley operation, and we've just arrived, and we're here with Steve Smith, who's a technical consultant, kind of the mastermind of the whole investment thesis, I would say, probably for Zimbabwe, for Kavango and Pambili. And so maybe you can just begin to characterize the big higher level opportunity with the gold occurrences in Zimbabwe and why it's such a good place to try to make discoveries.
Okay, big question, but I think I can start by saying that Zimbabwe's got 22 greenstone belts, comparable size to the Lake Victoria greenstone belts in Tanzania, which over the last 40 years have had over 45 million ounces of discovery. Here in Zimbabwe, we're standing about 20k south of Bulawayo now in the greenstone belt. There are something like 6,000 registered mines, many of which have been operated on a small scale during or between the wars, and we're running a high-grade, narrow lens mining. What the opportunity for us is, in terms of the geological opportunity, is to go to some of those deposits and look for bulk minables. In other words, areas where there aren't just narrow high-grade deposits, but there are envelopes of lower-grade material around them which bulk up, but much lower grade than they would have mined in the past. Sort of thing you see in Australia, where they've been mining open pits since Alan Bond started the super pit in Kalgoorlie. Here you can mine grades down to, at the gold price at the moment, gram per ton even, depending on how wide it is. So that's the opportunity, is to assess some of these old mines. You don't have to be a particularly clever geologist. Maybe I should resign now. You just go to some of the old mines, see if you can look at the alteration halo and the mineralization to see if it's wide or narrow, and then do some exploration based on that. Yeah. So that's effectively the bigger picture that we're looking for, is trying to consolidate some of those smaller mines from the past where they were mining at a cut-off grade of 6 grams per ton, to look at it with a more modern economies of scale.
Right, and then of course Zimbabwe has had this kind of turbulence over the years with hyperinflation and geopolitical events and so on, which has kind of forced this situation into being where there haven't been any modern investment and exploration here. But as it stands currently, what kind of difficulties does exist that you have to work around? I know that with the claims there's some troubles you have to go through and so on. Can you kind of characterize that?
Yeah, no, there are difficulties here. It's not necessarily easy, but it's my ex-partner, who's sadly deceased, has been mining here since 1966, and if you know how the system works, you can mine here and make money without a problem. There are things you have to do in terms of looking after the claims. There are many issues. One of them is consolidation. So the original claims were probably 600 metres by 200 metres. Now, to put together a modern open pit mine, you can't do that on a small claim like that. So you have a consolidation process to deal with. That's one of the issues. Then you have, during hyperinflation, when there was absolutely no money here, the government were running a paper-based system of claims control, and by the time they'd rubbed out and drawn the claims on 100 times, unfortunately a lot of the information was lost. So you've got to go back and do your research properly to make sure that you have security of tenure over your claims, and put up the beacons and do all the things you're supposed to do. But it's all doable. Yeah. It's you just need to know what to do.
It's a combination of fairly comparatively virgin geology, not too many people have picked it over in depth or with modern techniques, capital starved, and some kind of strange procedures when it comes to kind of claims and so on that makes it more difficult for exploration. But all of these things can obviously be navigated if you have access to capital and the competency. So it's very interesting. If we just zoom into this location that we're at currently, we're at the Golden Valley. If we just take a look at the regional geology here, this part of the greenstone belt, maybe you can mention some of the mines and some of the general opportunities that you see in the region, and then we can speak to Golden Valley itself.
Sure. Okay. Well, we're standing at Golden Valley. You can hear the stamp mill in the background down there, which we'll go and have a look at later. But if we look down the valley about 7 kilometres into the distance there, I don't know if you can see it, but that's the How mine, which was one of the biggest producers in Zimbabwe. It's over 1 million ounces, sitting on a shear that comes through here. Just that hill over there is the Khurukurt mine, which is an intrusive, which is there are tunnels mined all the way through that. You can walk right through that hill from one side to another. Just to the right of that is the Bonsor mine. Across the hill over here is the Christmas Box mine. Just beyond that is the Mount Morgan mine, which is a banded iron formation. Just down there in the valley is the Talisman, which was running at 40 odd grams per tonne in the oxide zone. Just over here there are some guys milling on a recent thing, doesn't have a name. So the whole place there's a plethora of mines around here. So there's lots of opportunity. We're all within easy trucking distance of Golden Valley.
And these operations, generally speaking, they are private companies. There are no very well capitalized groups, so they're smaller operations. Are they usually underground or small open pits, or is it a mix of everything?
There's a mix of everything. How mine was run up until recently by a company called Metalon. It's a big mine. All the other mines I mentioned are being run on small scale now. They were mined during the colonial times or between the wars, but now they're all being mined probably in an artisanal manner.
So in terms of the more significant occurrences in this part of the greenstone belt, which examples would you point to, and maybe give a sense of what resources could exist there and what has been pulled out of the ground there historically?
Well, How mine's the biggest. I think it was owned a long time ago by a guy called McLennan, I believe, who found a little relatively small thing on surface. He sold it, and when the guys as they went underground, it became wider and wider. And I think it's about a 5 gram per tonne mine, and there's 1 million ounces down there. Yep. So it's a significant mine for sure. The rest of them have just not really had the work done on them at this stage.
All right, so Steve, if we just speak to Golden Valley now, if we can just kind of begin, if you characterize on a high level what the kind of the gold occurrence is here. Why is it here? Why is it hosted here? And just speak to that first.
Well, not to go into too much depth, but there's a lot of structures coming through here, including the How mine shear zone, and structures coming off the How mine shear zone, which occupy these valleys. We'll see later that there's a north-south structure running there between the two adits that we'll visit later that could have some control on the mineralisation. So obviously with any mineral deposit you need a source, a plumbing system to move your gold, a heat engine to move it, and you need a trap site. And obviously we're not that far away from the edge of the greenstone belt here, which is where most of the gold deposits in Zimbabwe are relatively closely related to granite intrusions at the edge of the greenstone belt. Those provide the heat, and the volcanic rocks provide the source, and these structures provide the conduit along which the fluids move, and then the fluids are trapped either in minor structures or by chemical traps such as banded iron formations. We have a couple of banded iron formations running through here, through these ridges here, and on that ridge over there as well. So that's basically in a nutshell, simplistically, where we're standing with the mineralization.
Right, and then I should ask, in terms of what is known, if you just kind of summarize the data of historical activity that you have, kind of what you know about the gold occurrence currently. You can include what you know about the underground. Just point out the data points that you have.
Funnily enough, we didn't know tremendous about this place originally. It's mentioned in the bulletin, which the last bulletin is probably up to date, is before 1980, and it was running at about 9 grams per ton. And then it was run by an Italian family on a private basis. We know very little about it. Although when we first took it over, they came in and showed us where one of the adits was, because it was buried. So we managed to get into that and work out what was going on. So it's actually very much a suck it and see situation. Just up on the ridge over there, you can see the road. If we just move over here, in fact, where the road comes in, and you see those rocks on the top of the hill, there are some alluvial workings. In other words, places where the guys have been working gold off the top of the bedrock, which is obviously being shed by something up in that banded iron formation ridge there. Down in that valley over there, there's alluvial gold, so gold being shed again from that down into the valley. Then we've got this line of mineralization here, which hopefully you guys are going to fly over in a few minutes, where we've got a line of gold workings down in the valley at Delta Shaft, running up through here, across here, through Adit, the first Adit here on the east side, across the western Adit, and then up over the top of that ridge over there. Just over the hill we've got Christmas Box. Just down the road here we've got Talisman. So we've got an awful lot to look at here in terms of our focus at the moment is straight down on the mining. Try and find ores to go straight to the mill, but later on in the process here we've got a lot of exploration work to do and a good deal of potential.
So we're here at the Golden Valley mine at the portal. We're about to head down, but first we have to introduce Clayton and Dale. Dale's a mine geologist and Clayton is the mine engineer here, or mine operator. Yeah. So first of all, maybe you can just tell the story before we head in, and then we can just go down and observe everything in the mine.
Okay. So this was basically an old shaft. So we managed to rehabilitate this adit and do the concrete works just for safety reasons. Previously it was just a hole, So we managed to do the concrete for safety. So this is just an adit which stretches about 15 to 20 meters, and then from the 20-meter point we go. There's a vertical shaft that goes that's about 25 to 30 meters going down. So we did this because of mainly for safety purposes. Yeah. And
then how long have you guys been with Kavango and Pambili working with the companies?
Okay, I've been with Kavango for about 8 months now. Previously I've been working for other mines, Old Nick included and Zimbabwe included.
Right.
Yeah.
And you then?
Yeah, no, I've been with them for about 2 years now. I started in January of 2023. But like Clayton, we worked together previously on other projects for the past, it's been like what, 5-6 years now?
Yes.
In between we've like met each other throughout our careers on and off.
Right. And you're both experienced with mining as well as kind of the geological identifying or managing dilution and so on.
Correct. Yeah, that's something that we kind of worked on. We at one of our previous employers, we were like working in tandem in the same section, doing like grade control, and while Clayton was managing the section through mining and the engineering side of things.
Excellent. All right, guys, let's go down.
Okay, so we're just at the entrance of the adit. So we'll just walk you through. And we've got some safety signs on the wall as a matter of Ministry of Mines bylaws. The old entrance of the adit used to start over here, where these gates are. These gates have always been here, and we actually ended up putting this concrete in as Clayton mentioned prior, for safety, as well as just trying to keep things neat and tidy and to a certain specification so we can have some pride in our mine. Now, you enter into the adit straight into the oxides, where they were mining, the previous guys were mining before, and the trick with this is defining what the oxides are doing or where exactly is the ore carrier is very difficult. Now, if you look to my left here, you can see that they were just arbitrarily mining, hoping to find gold. Now, what you would have probably found is, as they were mining on the side of the hill here, they would have been taking some of the material to mill, and if that didn't come back with any sort of sample, it would have come back here and tried again. So as we transition through the adit, you'll see quite a few of these sorts of cubbies along the way. Now, we're using them as a secondary purpose, as a means of storing any equipment or ancillary pieces of metal, etc., that we might need or use in the future. So it's not very neat and tidy from that perspective, but it's a useful thing to keep out of the way of people's conveyance, and also whilst we're trying to move ore from the top of the shaft here out the adit. Basically, what we would have found is they would have developed this in some sort of a non-technical way, as you can see by this bend. But as we get round the bend and to the actual collar of the shaft, they would have actually found the ore body here and then started to develop it underground within into the transition zone and then into the sulfides below. Prior to our arrival here, this shaft wasn't very safe. We've now got two shaft doors on it, one of which is open, as we've just lowered a bucket down into the main workings. But these Mentis gratings have now been made safe. We've equipped it with a mechanical electric winch there. And then on the other side, we've placed timbers as a means of barricade, because within that tunnel there that leads to that travelling way where that ladder is, there's an actual holing to surface, and with that there are a significant amount of opportunities for rocks to cleave off the side walls, both of the hanging and the footwall, and injure our personnel or damage any of our equipment. So we placed these timbers for the protection of our personnel from collapse. So obviously coming down, we have the first travelling way. So all of our travelling ways are equipped with ringbacks as a matter of safety. This one traverses a total vertical distance of 6 meters. There's a small platform at the bottom, and then there's another longer ladder that goes down to the bottom of the shaft, which is a total distance of 22 meters, including this travelling way here. So we basically got 6 and around 16 meters from the ladders respectively. And obviously this keeps our workers safe and keeps them separate from our hoisting. So we've climbed down from the top on the ladder. We're now within the actual ore body. Ore body has a varying width. Its widest is about 8 to 9 meters. It shows the significance of what was here. They did extract a lot of tonnage at quite a high grade, and what it reinforces with us in terms of a hypothetical theory that will need to be reinforced by exploration is that this won't be a lone entity. We expect to find these throughout the tenure that we have under our management. So the way they had mined this was quite unsustainable, leaving these large voids and large overhangings. So to correct that and rectify it to a more formal and safer mining method, we had mined a subvertical shaft that's here on my right. That shaft goes down 15 meters to its bottom. And at its bottom, we've developed to the east and to the west along the strike, 5 meters each. And those are our current mining faces within this ore body. And in terms of hoisting, we haven't yet mechanized this hoisting apparatus yet. We are currently using a handheld windlass that pulls the ore to the surface here. It's then detached from the windlass, attached here onto this mechanical winch, and then hoisted to the top of the adit, and then subsequently transported out. We have furthermore conducted sludge drilling on each of the walls that are accessible. So to my right behind me here, there's about 4 to 5 sludge holes that each sludge hole's depth is 3 meters. We then sampled the sludge, and the purpose of which was to ascertain if there was any lower grade halo of mineralization that was perhaps beyond the extent of the current ore body. And our results indicate that currently there's no indication of that through through our fire assay. I think the highest grade that we've ascertained there was about 0.6 grams per ton, which is technically sub-economic.
Just going back, one of the opportunities in Zimbabwe is there are well over 6,000 registered mines, many of which have just been mined between the wars on narrow, high-grade ore bodies. The opportunity is some of those mines, many of which have not been identified yet, have got a lower grade halo material around the high-grade ore bodies, which needs to be explored for, and that gives you your bulk mining potential. Back in the day when it was mined, the cut-off grade was probably, with a gold price of about $350 or less, cut-off grade would have been 5 or 6 grams per ton, whereas current gold price cut-off grade, you can mine 1 gram per ton, depending on if you're doing heap leach or whatever else, in fact lower than that in some cases. So that's one of the opportunities, and that's hence the smeltery. And obviously, as you're mining these things, you have to keep a hand on the smeltery and diamond inside.
So prior to our involvement here, the previous operators used to use this ladder that's right in front of Steve there. Obviously, it's not ring-backed and hence unsafe to traverse. Also, it's using the same mechanical pathway as our hoisting arrangement, which is, again, unsafe to have men in conveyance and as well as ore being transported. And that then motivated us to build, or fabricate this ring-back ladder as a separate entity, as a traveling way, to separate ore travel with the hoist versus man travel via the ladderway. Okay, so we're standing at the mouth or the collar of the southern crosscut. The purpose of these crosscuts was to develop out as far as possible off reef, essentially, so off the ore body, to develop 2 drill platforms. So we were going to drill out to the south, and there's another crosscut there behind the camera at the moment, and in front of me, that's drilled out to the north. The purpose of which, through our geophysical interpretations and the current known information about the subsurface geology, there's 2 bounding shears that seem to flank this mineralization zone, the width of which are currently unknown. However, the whole point of drilling towards them was to perhaps pick up any parallel ore bodies that may lie to the south of our known mineralization as well as to the north respectively. So as we developed these crosscuts, we've sampled the sidewalls, and if you look carefully, especially on this eastern wall here, you'll see there's some red spray paint that demarcates actual sample locations that were taken along on a meter-by-meter basis. They were then sent for fire assay at a lab, and what we found is that this particular zone, before we blasted it, had a decent grade. It was around 5 to 6 grams per ton. So obviously, having found that, we decided that we were going to blast two small wedge cuts, one to the east and the other to the west. You can't see the mineralization on the western face too well, but looking closely here within the eastern, there's a significant amount of brecciation. If you look actually on the wall, the face of the wall rock there, and upon closer inspection, you've got different lithologies. So we've got bands of what would appear to be graphite that have been mineralized along by this finer grained pyrite. Within the middle of the actual face, we've got a highly brecciated quartz that's obviously been reworked, so it's undergone some re-shearing and then hence has a sugary texture to it. And then within the interstices and the joints, you'll see there's quite a significant amount of pyrite mineralization coming all the way through. You can see this gold, fool's goldy sort of color, all the way along these cleavage planes that seem to be, it varies from quite disseminated, quite coarse, to quite massive and fine, but quite restricted to these zones. So these are still currently works in progress to understand the controls of the mineralization, as we've got several generations of breccias within our ore bodies and within the general geology. Taking you further down this crosscut, we've decommissioned it as a drill platform. And the reason for that is at this point here, we enter into quite unconsolidated ground. You can see it's quite fractured, a bit muddy-like. And that's the influence of the graphite that actually doesn't consolidate and hence provides a fall of ground hazard. And that continues throughout, and eventually at this particular point we've entered a fault which is supported actually by the surface mineralization, where we've got rivers that seem to have a certain jog to them. And this fault zone is obviously very dangerous for any man to work in. So we've decommissioned it from a safety perspective. And I mean, you can see here on this wall, we've got completely unconsolidated graphite. So graphite obviously poses a huge threat to one's safety. And within it, we can't have men working here. So unfortunately, this particular drill face is no longer available for us for diamond drilling. However, all is not lost. The trouble, or not the trouble, what we're finding within these crosscuts is several different generations of pyrite mineralization, some of which contain gold, others don't, and that makes it quite tricky for determining the actual gold carrier here. However, as our work on goes and we actually narrow in on what does contain it, we'll then have a better picture of actually what's going on here. It's quite a complex geology nonetheless. Okay, so we're going to go to the north crosscut now, and this is currently, we have the same sort of system that we had in the southern crosscut, where at the mouth we had significant grades of up to 40 grams a ton. So we've done exactly the same what we've done there. We've punched 2 wedge cuts to the west and to the east, and those are also contributing further to our current area under study to better understand the geology and controls and the mineralization. Added to that, at the end of that crosscut, we have a jackhammer that is currently drilling the cubby, from where we will end up diamond drilling out to the north in sort of a fan orientation. So we've got flat holes planned as well as down holes. And further to that, we want to turn when we put the diamond drill rig in there, we want to turn the rig around and drill under the ore body to detect any sort of down dip extension. This ore body seems to be quite vertical, so it's a bit of an unconventional thing to do, to drill into a footwall rather than a hanging wall. However, given its dip, it shouldn't affect the apparent width too much. So I can take you through there now. So similar to the southern side, but significantly more complex in my opinion. We've got a clear zone of mineralization, quartz bearing with carbonate, as well as some sort of significant faulting that's occurred that's then just disturbed all of these rocks, and hence made them a bit risky to actually mine here. We have taken samples here, but the grades that have been returned aren't extremely high. They're not as high as we thought we would be, but such is the nature of gold. It's not a continuous system of dissemination where the grade is consistent. But similar to the southern crosscut, we've got within the quartz, there's pyrite, there's a bit of arsenopyrite, a range of coarsenesses from quite fine to medium grade. And those are obviously what we would ordinarily look for in any sort of gold-bearing mineral system. However, this hasn't returned the highest grades thus far. That's not to say that it won't in the future. We just need to further develop this and understand what exactly is containing the gold in terms of these minerals. So walking further along, we've got two gentlemen. One is our operator, the other is his assistant. Hello, gents. How are you? Very well. So the plan here is we had reached the end of this development, which is behind them, and in order to prepare the cubby, the drill operator, the guy that wants to do the diamond drilling, requires a cubby to be 3 meters wide by 3 meters high, so that he can further establish his rig and have it supported properly so we can actually drill. So what they're currently doing is a process known as sliping, and in so doing that, they're going to drill 25 holes that will then be charged with explosives and each blast, a wedge of broken rock will come out until we get to such a point where we've got a 3x3 cubby from where we can then conduct diamond drilling. Now the plan for the diamond drilling is to go straight out in that direction, so that's like roughly to the north, and then adjust it depending on what we find there and the orientations of the actual minerals within the first core. We will then decide our angle in terms of azimuth to go towards the east or to the west, and like I said prior, then turn the machine around and drill under this ore body that we were standing in earlier to just better understand what's going on there. I'll walk you through before they start. So basically what we've got here is an air leg. This is all driven by compressed air and then water as dust suppression. So the whole point is this rock drill basically rotates at a very high rate of revolution and at the same time hammers, and that therefore develops the hole within the rock face. They're drilling this one. It's a 1.2 meter jumper or drill steel, which will ordinarily, when charged up, blast out about 1 cubic meter worth of rock. I'm just going to wait for them to start. So ordinarily you have, this air leg's job is to keep, it allows the rock drill to drill horizontally in most circumstances, and also it stops the operator from having to hold the drill on their shoulder, because these machines are quite heavy. We've got water coming out of the end now. So within each drill steel, there's a hollow tube that then passes the water through. And as I said prior, it's for dust suppression. As some people don't use water, and you end up having really bad issues with inhalation of dust and all those sorts of things. And there's all sorts of conditions like silicosis and meconiosis that you can get from that. So we're trying to protect our workers as much as possible. They're all equipped with earplugs as well, and safety tools. So these uniforms that they're wearing are like a synthetic canvas that allows water just to run off them, so they don't get wet, as the conditions can be quite cold.
In terms of ore handling, we do manual lashing. So we use a shovel and a bucket. So the guys they fill up the bucket and then we hoist it using a winch. So now the challenge that we have using this type of mining method is conventional mining method. So in terms of tonnages, it limits us. It limits our tonnages in terms of pulling. So now we're just going to see one of our guys lashing into the bucket, and then we're just going to show you how we do our hoisting.
And I used before, in terms of once you're kind of 3 shifts fully operational again, how much ore do you think you could pull out per day in the mine?
Okay, for right now, currently we just have 1 jackhammer. So 1 jackhammer, when you drill and blast, we expect it to produce about, since we're still developing, it produces about 10 tons per blast. So that's the 10 tons that we blast. There's a night shift that comes in and hoist outside to the surface. Okay, so
right now 10 tons. But once fully operational, can you increase that significantly, or what's the?
Yes, after we've developed, after we find we've measured our reef, our resource, then we're just going to do the proper mining, whereby we're going to do an under and sub-level stopping. And when we're stopping now, it's production. So for each and every jackhammer, it produces about 30 tons after drilling and blasting. So maybe for 1 shift, it's going to produce 30 to 40 tons of ore hoisting outside.
And to clarify for people, I mean, you can do 3 shifts per day, correct? Or 2 shifts?
Yeah, currently we're doing 2 shifts. There's a day shift and night shift.
Yeah.
So day shift is mainly for drilling and drilling and blasting, and then night shift they come and do the lashing and trimming and hoisting.
There's an interim period of about 4 hours. That's like a standard re-entry procedure that basically involves the degassing and exsolving of gases like carbon monoxide and nitrous fumes that are obviously present after blasting. So that then obviously eats into the total time that's actually allotted. So you don't actually have 24 hours to mine. You've basically got 20 at best. Alternatively, as we develop and we get into more areas where we can actually run the production, we would significantly increase the development ends or the stoping ends that we can then mine, and that would ultimately allow us to have those sort of like a swing shift, a sort of a morning shift, an afternoon, and then a night shift that would still allow the 4 hours for blasting, or the degassing thereof.
Yeah, so just to confirm, once you are back in commercial production, so to speak, with the current stamp mill, but in terms of mining and blasting, you can pull out 60 tons of ore or something like this per day out of the mine. Is that fully operational again?
Once we're fully operational, we'll be expecting maybe to do maybe 4 jackamas. So 4 jackamas, that's about 30 times 4, which is about 120 tons. Yeah. So yeah, so for shift, you can actually target to waste maybe around about 80 tons per shift.
Okay. So on a daily basis, that would mean 2 shifts, that would mean 160 in that case, or just above 100 tons.
Yes, for in a day, you just say 120 tons.
And then just to ask everyone here, I mean, you can involve anyone in the conversation, but in terms of actually developing beyond that, what kind of changes of infrastructure would you need to implement to increase the tonnage potentially out of this mine? That's a bit more down the road, but still.
Yeah, I think, look, this winch that we're currently using at the moment is quite slow. It's not very fast hoisting, and at this shallow depth, if we were to increase depth, it would obviously take significantly longer to hoist. So if we were to increase our hoisting time, as we increase our distance, that would obviously help a lot. Also, the volume of the bunga or the bucket that we're currently filling is quite limiting. If it could be a ton or 2 per load that goes up to the surface, that would obviously increase your output tremendously. The alternative is to have another completely separate operation that has its own system for hoisting that could then double the production, given that it's got the right mining ends to actually mine. So we would need a significant change in the methodology of our extraction, and then a real long-term possibility is rather than using vertical hoists and shafts like this, we could go into like decline mining, which is obviously a significant capital outlay, but what it gives you is a massive amount of tons at the end of the day. You can essentially, you can blast and hoist as much and transport rather as much as possible. Your only limitation is the ground that's available for mining. That's a much more down the road sort of model, which would require like a more proven resource as opposed to currently what we have.
And then just to recap, so the activities underground here to get back into production, because the stamp mill is essentially operational, you can get going there, but you need to define the ore, the source of the ore. So what's the timeline for that currently? When are you aiming to get to that place where you're ready to start, breaking ore and focusing on mining?
So in terms of defining the actual resources that we have currently, that will be informed by the diamond drilling that we're about to commission, which should be done in the next couple of days. The rig is due to arrive very soon. And after that, once we've got a genuine intersection that we can develop towards, then we'll be basically in production. Because once we intersect that intersection from this crosscut, as is where we're drilling from, we'll be able to then to mine in either direction, and therefore develop our main drives. And ultimately, if it's within proximal distance to this sub-vertical shaft, we could mine from here, this vertical shaft, towards the intersection, and then that would then technically give us a stoppable block that we could then define and then get into actual production rather than development. So timeline, it's a matter of months if there's an intersection that we're looking for that has the significant width and grade, which is obviously the 2 parameters that we're looking for that inform the tonnage and the actual productivity of the operation.
And how many holes are you doing now, and what's the kind of the spacing between them?
So for now, given that we're drilling from underground, we've planned for a total of 5 holes. They obviously, we can add to those. So the preliminary plan is to drill flat holes that are slightly up dip, just so that the holes can drain. So we plan for 5 degrees up dip. The initial program is for 100 meters per hole. It's a BQ or core size, so your limitation is obviously the depth of hole. And then the down holes we can adjust according to what our flat hole intersections are. And then the hole that's going to essentially traverse underneath this ore body it will be down dip at around minus 65 or minus 50, depending on the flexibility of the diamond drill rig. So for now, it's not really resource drilling. It's more development. It's exploration for development rather than exploration for resource definition. Ultimately, there is scope, though, funds and etc. permitting to then diamond drill from the surface, so that we can have a series of holes along strike. What we have found, though, is that there seems to be 2 different directions of mineralization here. On the surface, if you look across the river, there's actually another Adit who's got 2 different directions of mineralization. One is basically going north-south, and then the other one is consistent with this more easterly-westerly sort of direction. So we have preliminarily provision for surface holes, and if we do find that if the funds are available, we will drill them. And their current spacing is around, it's 150 meters apart, and if we do find that they have intersection, we can then narrow their spacing and infill drill accordingly to actually define a resource.
And can you just give some context, because I mean, with small scale mining like this, you need to control for grade dilution. So can you speak to the visibility of the mineralization once you actually can see it in the wall, and how you control for grade dilution, your experience with that?
Okay, so like ordinarily, the method that we use when we actually mine along a development, so it's a bit different than the crosscut, because they're actually across the actual regional strike. When you're mining along the strike, we try and the miner or the mining crew maintain the footwall contact at all given times, and that's normally a very clearly defined line where you see your country rock is quite well defined. And in this case, it's a lot of a case of just visual assessment. Obviously, we back that up with sampling. So ordinarily, we'd have a geotechnical team down here with a sampler. They come and they sample across perpendicular to the actual dip of the reef into both contacts, and then we isolate each lithology within the face. So if we've got multiple lithologies, those are sampled individually, because there'll obviously be different mineralizations and potentially different gold carriers, if not only just one gold carrier. So generally in this instance, it's quite easy to see what is and what isn't potentially gold carrying, but there are obviously instances where it does become a bit more complicated when you're encountering a fault or a dike. We get these sort of mafic intrusives that come across and truncate our mineralization. That then changes things up and requires a little bit more interpretation, and it's almost, it's a luck of the draw sort of development that we have to then ascertain if we don't have any prior information. And that obviously then reinforces the necessity to have drilling for exploration drilling for development, because ordinarily you want to be drilling ahead of where you're mining, so that you can anticipate these sort of changes in the geology that are influenced by faults or mafic intrusives respectively. Yes, and obviously as we're developing, prior to any sort of stoping, we should be drilling sludge holes into the hanging wall and the footwall to see the true extent of the mineralization, and that then helps the miner when they come to do their stope preparation on the top sub level. They ordinarily would go and then slipe that, so to avoid unnecessary dilution. If we know the extent of mineralization in the hanging wall, we can then slipe it accordingly, so that when he drills his wedges, we know exactly how deep they should be and to what extent they should be blasted to, so that we can minimize dilution and maximize our output.
Okay, so we've just left the East Adit, where the focus of our current development is. And if we look across the valley, just behind Steve, we can see to the right a big collapse. And that was where the previous shaft was. And then to the left, there's some concrete structure. That's a housing, effectively, of what we call shaft 14, which is sunk to develop and get access to the mine below the collapse. Steve will talk more about that in due course. And you can see to the left, you can see some fresh rock that's been taken out of the shaft, that's been redeveloping it, much as we did on the East Adit.
Okay, so we've just come up from the you can hold that, John, from the East Adit, which is orientated east-west. Across the river is orientated more or less north-south, and obviously the river has exploited a structure. And on the other side of the river, we've got the western adit shaft 14. And in that particular adit, there's quite an extensive system of old stopes, and there is mineralisation's been mined in two directions, east-west and also virtually north-south. So at the moment we're busy equipping that. But what might have happened, this structure here, the north-south one, may have been the conduit for the mineralising fluids, which have now leaked into the east-west, and this north-south one might be a parallel. And we might have potential for further north-south structures further along strike. So that's one of the things we have to investigate. So the plan there is we've got to do some survey to establish exactly what is going on down there, some sampling, and then we'll plan either some underground drilling or some surface drilling.
Okay, so now we've moved over to the western adit, just across the river. So from this side, there's another adit that they did. The guys that were mining here previously, they did an adit here. But if you get inside, there's about 4 drives that were mined. But just because of the oxidized zone, it's actually weak ground. So there was a collapse inside there. So after they encountered the collapse, they decided to come the other side. Then they did a vertical shaft going down. Then from the vertical shaft, they did a crosscut, trying to come and intersect this reef that they were mining this side. So from the vertical shaft, there's about 15 meters. Then they did a sub-vertical shaft. So we have been trying to continue with the sub-vertical shaft so that we try and intersect the reef.
To clarify for people, I mean, this is essentially a duplication in terms of what exists here that we saw previously in the first shaft, in the first drive down. That exists here too, but the plan is to get that into like straight commercial production first, and then go here and refurbish everything as well. Absolutely. So we're following the same pattern. As we get to the shaft, Clayton will explain more of the re-timbering to make it safe. As with the previous shaft at East Adit, it was very unsafe for working. So yeah, the idea is to get inside there, clean it up. We've already started we've completed an underground survey. We've done some sludge drilling. We're planning some sludge drilling. Clayton will tell more about the development we're doing there. But yeah, it's a duplication of what we did on the other side, and hopefully we'll extend that duplication to the underground drilling as well, and try to match the two results to interpret future ore bodies. What do you guys know of the historical production here on this side, and maybe you can put that into relation with what's going on the other side as well? Dale, can you answer that maybe? Historically? I think we know the total production. I'm not sure where it came from. No, you won't know. It's come from both sides. Yeah.
So we don't have like a total tonnage that was mined, but it's quite these tunnels are quite extensive. They're actually stoped inside there as well. Yeah. And we do have some old material that we currently are looking at retreating. That was processed from this adit in that shaft, and it's quite high grade. So definitely there's definitely something significant within there. It's a matter of finding it again, and then first making it safe, and then we can start mining there as well. So as you can see, it's quite oxidized. Prior to this entry point here behind, the original entrance was over there, where this cavity is here. Unfortunately, there was significant collapsing that occurred there during blasting, so they had to actually change entry point, and then as Clay's explained, then this became unsafe, and they ended up dropping the main shaft on the other side there that we call shaft 14 down to intersect the ore body. So essentially, if you summarize, what would need to be done to be able to safely go down there and start working, or doing the same work, sort of to access, and then start the process of finding
ore material?
We've got two approaches that we're playing around with at the moment. It's basically dependent on funds, also just the matter of being pragmatic. Currently, we were about to start channel sampling within there. If we find that the channel samples within all the drives are pay, we might end up just taking this entire hillside off because it's so oxidized. It can basically be dug with an excavator. There will be some areas where you can see the obvious hard rock, and on the other side of the hill there's a lot of dolerite float that's come down. So this is bounded by a mafic intrusion at some point, or truncated thereafter. But should we not be able to mine it all out completely, we would need to reevaluate our entry points. So this is a bit difficult to operate out of right now. We have to widen this adit entrance, and then we need further to that to establish the grade of each development drive. And once that's done, we can actually end up mining underground using this shaft 14 as access to develop drives that are currently beneath these workings, which is the whole point. We'll go around to the shaft shortly, but should we be able to do that, we will have opportunity to actually conduct some stoping to really get a feel of what the ore body actually contains outside of the offsites. Okay, so we can go up now to shaft 14. This was in quite a bad state when we first came here. We've replaced all the timbers. Similar to the sub-vertical shaft at the east adit, we've got a windlass. It's obviously quite manual. Accompanied by that, we do have a travelling way, and obviously we have a little bit of a discrepancy there with men travelling in conveyance as well as a hoisting way. Obviously we schedule our travelling so that we don't ever find that we have men travelling in the shaft at the same time as hoisting. Basically, it's more of a prospecting shaft for the moment. We are limited by what a windlass can hoist. So it's basically to understand what's going on in the greater ore body within the west adit. We do see some sort of continuity between these two adits, the east adit behind the camera and this west adit and the shaft. However, I believe this river is obviously following some sort of a structure that runs along the same sort of dimensions as the actual mineralization. That's clearly truncated our known mineralization at some point. But for what it's worth, the work that we have done here has fundamentally been to make it safe, so that we can actually operate underground without any sort of danger to our people. But ultimately, we do want to shift away from the shaft mining and go back into more adit-based mining, which is less mechanical, less labor-intensive, and allows us to actually move more tonnage out of the ground at any given time.
Hi, my name is Wayne Jardine. I'm the company engineering consultant and been on the project from the start of the concept. Basically what happens at this part of the mine is this is our very rudimentary basic milling operation, and it's when I say it's rudimentary, it's just basically to mill and prove what we're getting so that we can get a concept of the grades and then decide what size plant to put in later. So there's a dumper, those dumpers over there that get loaded from the bottom and where the mining process is going on, gets taken up here, up this ramp, and gets piled here, and we run the ore through a crusher. From the crusher, we put it into a very small ball mill. This ball mill is only capable of running 0.5 ton an hour. So it limits us to a 10-hour day of maybe 5 tons. But it's enough for us to be able to work out where the value is, and for us to be able to see what free gold is, and to see basically which our way forward when we know exactly what we're going to get. From there, the slimes that are milled go out into the settling tank so we can recycle the water, and it runs around. So the ball mill is what it is a series of liners inside there, and the ore as it goes through starts off at the small crush size of maybe 10-12 mil. It's going through and it gets crushed down by the balls that are rolling and smashing it. Out the end, anything that's oversized that didn't get crushed will come out the end and collected here. Shouldn't be much there because that's the process, it shouldn't be there. the small fines are going through here. They're going into a concentrator. The concentrator inside here is basically just a spinning bowl with a series of I'll show you the fingers now and how it works. Comes through here, drops into this. This is spinning at about 120 rests per minute. I'll show you the inside of it in a minute. Inside here, as it drops down in the center, this is spinning, and the gold and the heavy stuff will sit at the bottom. The dirt will climb up the sides, and your slimes, which are now barren, not containing any gold or heavies or concentrates, will go over the edge and out to the dump. All the gold should be sitting on the bottom. That's how a concentrator works, and then you wash that out whenever we do a cleanup, which is the end of the running day.
My name is Fulton Msabayana. I'm the plant manager for Kwazulu Valley under Pambili. So basically, this is our gravity concentration unit. We'll be able to tell how much free gold we're able to get from the ores that we're bringing from outside. As Wayne said, it's an indication on how much free gold we are able to recover before we go to the leach section. So from this design, we'll be able to upgrade it probably into a pilot scale and a larger plant scale at a later date based on the findings that we are going to do. So this is where we'll get our free gold. That's the gravity concentration unit. So afterwards, we are going to the tailings, which where Mr. Wayne was talking about, where our stuff without free gold has been deposited into for leaching.
You're going to see the rest of the operation, how it works. It's a very simple operation. It'll obviously be stepped up once you know tonnage. You don't want to put in a big tonnage plant in the beginning and then not find you can supply enough ore to it, because a ball mill cannot run half full. It's got to run at maximum capacity the whole time to last. So this is a static leach process. So the sands are taken from the settling tanks and put in here, and from the stem mill operation, which are outside, which is sands and slimes mixed together. They put into a leach tank, and as cyanide is added, we get a caustic level right to get your pH correct. And our gentleman here will tell you, he is a metallurgist, he'll be able to tell you exactly the best extraction methods. And we leach that, and you'll be able to carry on from there, explaining how the process works with the capture and the carbon.
Basically, we have got 7 tanks, of which each one, the capacity is around 18 tons per tank. So we're looking at probably around 128 tons in totality in terms of the actual capacity of the circuit. So what happens here is per each tank, we've got a filter bed dressing, which is able to clarify the solution, the solution, the thing that has been leached. So basically, there are a lot of tests that we do, a lot of sampling exercises that we do. Basically, when we load the tank, we check out the head grade based on from each tank how much gold we are able to get from each tank. Then as we run through, we're able to monitor the circuit in terms of solution grades. Periodically, we do that through the laboratory, where we submit our samples to the lab, and then they determine how much gold is in solution. So everything that is done from this end starts from, in terms of sampling, that's very, very important. The sampling exercise, we do sample the solids, we also sample the solution, the pregnant liquor that will cascade through into the clarifier. I will take you to the clarifier so that you can see what is happening from that end. What we have here, we've got perforation pipes that are fitting the pregnant liquor into one clarifier. So we've got different sections that we take samples from, so that we assess how much gold is left or not from our sampling exercise. So as you can see, all this solution that we have here is the pregnant liquor. So from here, the liquor goes through to the carbon room, whereby I've got an extractor box which has got compartments. I think our engineer can specify more on that, on the design and what happens inside there.
So basically a carbon box which is inside the room here. There's a series of weirs where you have carbon in different compartments, and as the gold goes through, you capture a certain percentage each way going through to the end. What comes out the end should be barren if you've got all your numbers right, and it normally is because we get our numbers right. That's the gentleman's job. And each tank, when it reaches a zero number and the gold has basically leached all the gold out, that is then sterile, is out, taken away, and its next tank is put in. So we try and carry a constant flow of a certain amount of cubes a day, so that we can calculate what our gold extraction is. What we have here is a 1450 stamp mill. It's a 3-stamp stamp mill. It was designed in the late 1800s. It's probably the most efficient, reliable milling setup type plant you could have in Zimbabwe. It's very basic. It only works on basically the energy of the 1350, that's 1,350 pounds of each shaft dropping down and crushing the ore. It's called an open circuit mill. So the advantage of an open circuit mill is this kind of ore that we're running out here is ore that a contractor brings to the mine, and it belongs to him. So we're milling it for him on a contract basis, and he wants to be able to watch his ore the whole way and know that there's no chance of anybody taking it away from him or stealing it or doing anything. So this open circuit, he's able to visibly see it the whole way through. It's a very simple system. They take the ore in that size. The mill can crush very large pieces. It doesn't have to be fine crushed like a normal ball mill or a closed circuit mill. They hand feed it. This mill will run at about a ton to 1,200 kgs an hour. It goes through the mill. On the other side, it's been ground. Doesn't get ground very fine, which is it's good for the company because it's going to leave a certain amount of gold in the tailings, which are going to be piled over there. I'll explain how that system works when we go to the front. This table on the front, the table that from the front of the mill, where the screen is there, we have no connection to it at that stage because that's the contract miller. He wants to control it. He's got locks in there. Those locks are closing the plate off, and inside here is blankets, and there is a green mat which captures the gravity gold. As it goes through, basically by the time it's left that table there's no free gold left in it, and it's all any gold that's left will be inside the tailings. It goes through a pump behind us, gets pumped from there, the water settles, it gets onto the dump. Those dumps are to let the tailings dry out and oxidize. Once they die dry, we'll take them and run them back to the tank. Because of the shape of the dump, and we have a system where the water is going back and recycling, and we're able to recycle the water.
So basically what we have here is the sands that are coming through. So at this phase, basically what we're doing is we're depositing our slimes, which have got gold in them. So after that, there's clarification that happens in the respective ponds. So after that, we offload manually using shovels of the tanks, and that's the stuff that we take to the drying pad. Normally the drying pad is over that side. We can go there and see the site itself. So we've got a paddock system. What we interchangeably deposit from that side. Once it's full, we move on to the next paddock. So these are the paddocks that have been offloaded. So basically, it's a manual way of doing things, whereby after offloading, we use a tractor, load into the tractor, then we take the material for leaching to the leach circuit. So this is what we have from this end. But with time, as operations increase and the capacity increases, we might have to do away with this kind of deposition, and then we implement the proper setup based on the modern mining ways of doing things. So it will be upgraded with time over a period of time to a bigger setup. So the stuff that we have from this end, these are old slimes that we were mined some time back. I would like to say probably 15 years or so. They have oxidized over a period of time. But we have found that they still have got value in them. So what we normally do to augment our production from mining, we blend together the material from what we're getting. Normally the stem mills can give us about 12 tons a day, 12 tons per mill. So what we do is the material, we blend it together to augment that 130 ton plant a day. So we blend together the material and then we reach that site. So basically this is what we have from this end.
So now we've essentially walked through the mine shaft, we've seen the workings and so on, and the access down to the mine. We've also seen the current state of the operations here. So I think let's reflect upon that. So if we first talk about the current constraints, we established sort of the constraints down in the mine. You see a pathway with some limited investment to sort of potentially pull out 100 tons per day in terms of mining. The constraint is finding the ore, right? And you have the drill program designed for that. Yes. You'll follow up with more work and so on. So we understand that you can potentially pull out 100 tons per day out of that mine, right?
Yes.
Maybe you can clarify what sort of things actually needs to be upgraded in the mine to be able to bring out that sort of volume if you have the ore.
Sure. So as you saw underground, the process is very manual at the moment. We're using these bungas, these what are they, conveyor belted buckets to bring up ore. So you're very constrained, very manual. Obviously, to achieve anything like 100 tons per day, we've got to change that mechanism. We're going to have to probably mechanize a bit underground, at the very least, bring in wheelbarrows and bigger buckets to bring stuff up. In the fullness of time, we'd put in a proper shaft with a proper ore hoist, probably with tramways and cocoa pans, which would then load into a rail, probably outside the adit, and then offload there into a dumper to bring it up to the site. Historically, before the collapse or the opening of the underground, the shaft headgear was sort of just over the side behind those trees there. And there's potential to reinstate that haulage or that shaft. And Clayton perhaps talk more about that, and that will bring it through. So Clayton, if you just explain a bit about the potential for bringing the ore up.
Yeah, so there's a vertical shaft that the old guys that were mining here, that they did. So we can actually equip that shaft and put a proper headgear so that we improve on our hoisting. We can actually put rails so that we install skips that will be hoisting our ore from underground.
Yeah, and talking about rails, you can then have them discharging into an ore bin at the headgear, and then that should be trammed to the site. So again, you've minimised your double handling.
Yes.
So that's one big efficiency that needs to be made from the point of view of underground. Once the ore gets here, of course, the other constraint we have is the plant and equipment. And behind you've got the jaw crusher, which as you can see is fairly small. The good thing is that they're relatively cheap, particularly in Zimbabwe. So we can very easily upgrade this or these crushers as required without too much capital. The next bit of constraint is the ball mill, which we spoke about before. To be efficient, it has to be running at full capacity. That mill runs at about 5 tons per hour. You can't run it half empty. It's not good for the mill, and you don't get good grinds. So obviously you need to have, on a day, 10 tons a day minimum to keep that thing going. You could double up if you wanted to, depending on the ore supply you had, but equally you could just get a bigger mill. Once again, Zimbabwe is a mining country. Mills are relatively cheap and readily available. So obviously they cost money. We'd spend that money once the ore justified that. We saw the gravity separation circuit. That can also be upgraded. And ultimately the main efficiency will come through from the batch processing. Vat leaching can be efficient, and someone like Fulton, who's applying new or better process checks and technology in terms of preparing and testing the solutions, we are getting better grades already and better recoveries. But obviously, if that was a continuous process, we'd improve on that further still. And that would be the next sort of level. But now you're talking about a full carbon and pulp plant, which you're probably looking at a minimum of 100,000 to get one of those in. And again, we do that once the volume of the ore justified it. So the good thing about this plant, probably doing about 150 tons a month through this circuit, and about 450 on the toll milling circuit.
Yeah.
If we get a sufficient ore, we would stop toll milling, and we put our own ore through that. So we'd recover our own free gold, and then we processing the sands as we do already for third-party miners, but we'd have the benefit of that. So although I talked about increasing the capacity of the stamp mill and the ball mill, before we did that, if we had sufficient ore, we would augment that capacity by using the stamp mill.
Yes.
So that could potentially take us up to 450, 600 tons a month, you know, running at hopefully 5 grams per ton. And you know, you can do the math, and that's a big uplift from what we're doing at the moment.
Yes.
And bear in mind that we're doing at the moment, we pretty much the last month we got enough gold more or less to cover our operating costs. And that's the intention for the next couple of months, that with the improvements that we're making, with once we start getting some ore as opposed to processing development material and these old sands, that we will start washing our faces, as they say, and that the money that we're coming in for exploration and development will go towards exploration, development, and that's for working capital.
Right. So, just to give a sense, what would be the kind of the ballpark cost if you wanted to get this plant able to process, say, 100 tons per day? Do you have a sense of what quantums we would talk of?
I would think, you know, anything between 100 and 200,000, and it depends again on how efficient you want to be, and it comes down to capacity.
Yeah.
So, you know, obviously a 100 ton a day plant is going to cost you less than a 200 ton a day plant. But we may go for the 200 ton a day plant if there's enough resource to justify that.
Yeah.
Because it's easier to get source ore from outside to make sure you're running at capacity, and then wean yourself off that as you develop your own ore supply, than to fully maximize your plant within 6 months, and then you've got to go and get another 100,000 to build another plant because you haven't sized it properly. So a lot of it is iterative. Obviously, we need to find out what we can do, but we're not. There's been too many plants places I've seen where they've spent money on a big CIP plant and they haven't been able to mine anything, and they've got $100,000 plants sitting there doing nothing. So we work the other way around. Get the ore, process it. If we need to increase capacity, we'll try and do as much as we can from cash flow. And obviously, the things that don't generate the cash originally are things like exploration, and that's what we use to raise the money for. Yep. But generally, you try to do things through cash flow.
Excellent. So it sounds like the biggest capital spend and probably effort as well is to find the ore. That's basically that's a big task.
Absolutely. Yeah.
And then to incrementally upgrade production, you can do it. So.
Yes. Yeah. That's fine. And the advantage we've got, you know, this is not a greenfield exploration site, right? We know there's production. There's ore here. We're recovering gold already from waste material that's basically lying around. So we're confident, and the team here is confident that we can do stuff. As I say, just by putting a bit of effort, bringing some people with experience on board, we're already seeing a step change from what it was, 6 months ago when he first came here. I'm very encouraged by what we're seeing, and I'm very excited about what the future's going to bring.
Excellent. In terms of the longer term or bigger discovery potential on the property, where do you see that that's most likely to take place, and where do you think one should look? And can you give us an idea of scale, assuming that these structures are gold bearing?
Sure. Well, we've got at least a kilometre of strike here, and we've got these two big blows, if you like to call them, in the adits there, where the mineralisation at one point is 8 metres wide. Now, if we can work out and we've got a continuation of mineralisation along strike here, potentially narrow, we don't know, but if we can work out what's structurally controlling the 8 metre blows, and we can find a few of those, we can rack up the tonnage quite considerably. So that's what we have to focus on. The nice upside story would be something similar to what they found at Howe Mine, where on surface the footprint of the thing, the original body was relatively small, and now it's down. Don't know how many levels they are down now, but it's a 1 million ounce producer. So at this stage, we don't really know what the potential is. There is potential here. That's the most important thing, and there's a lot of potential around it to add in, to truck stuff in as well.
And the pathway of figuring out that potential, I mean, have you gotten to the point where it's mainly time to drill, or do you still need to do would geophysics potentially be effective, more mapping, more soil sampling? I mean, what kind of work would you see to get to that point?
We've actually done quite a lot of work. We've done a drone survey, ortho-rectified photography with a DTM, a digital terrain model. We've done a magnetic survey over the prospect that we've got at the moment. We've done geological mapping, we've done geochemistry. So we're now really in a phase where we want to do the underground drilling because we want to focus on tons to the mill, And from there, obviously we need to raise some more money to do that. We need to drill the strike extent of these surface workings. Down there in the valley at a thing called Delta Shaft, which hopefully we'll have a look at a bit later on, we picked up some grab samples running 60 grams per tonne. So we need to follow up on all that sort of, all those occurrences as well. So we've still got a lot to do, and it's an iterative process, and it takes a little bit of time.
But it's fair to say at this point that you have more, probably fairly good ideas in terms of spending money drilling than you can afford to pursue at this point in time.
Absolutely, yeah, there's not a problem with that. We've got lots of drill targets. We've got parallel shear zones to this that we can drill from underground. We've got the surface traces of this shear zone we can drill. We've got whatever's shedding gold from that hillside up there to test. We've got Delta Shaft to test. We've got the north-south structure here as to whether that's got any control on the mineralisation for the adits. So yeah, we're not short of targets, that's for sure.
All right, so let's head over and take a look a bit closer at the various key ideas that you have and speak to them up close. Sure.
Okay, so we're standing at Delta Shaft, which is on the eastern end of the property. We think it's a relatively narrow zone, but we haven't done any work here yet. Any exploration work as such here. Clayton's been down and done some shaft sinking, a little bit of shaft sinking here. Yeah. And it would appear, looking at the material there, and there's an old dump, that potentially the mine started here originally. We're not 100% sure, that's the rumour. And there's a quartz vein down there. We're also seeing wall rock with little rusty specks in it. Those are little tiny boxes after pyrite. So it's got sulfides in it in the oxide zone. One of the samples coming back from the little bit of sampling we had done here was about 60 grams per tonne. And it's a long strike from what you've flown from the top of the hill when we were on the vantage point and you flew along the strike. This is the far eastern strike extent. So at some stage we're probably going to have to do some surface drilling underneath here to see what the down dip continuation would be. Or we can carry on with the shaft sinking. But at the moment it's some distance from the plant compared to where we're working now, so obviously our main focus, as I said earlier, is to get material to go to the plant. But this is a target to come to later. Yeah. Okay, Clayton?
Okay. Yeah, so what we did here, similar to shaft 14, we made safe this shaft. We did timbering just to the bottom of the shaft. The shaft is about 18 to 20 meters going down vertical, and then we did drives in the eastern side. So this western drive, eastern drive at 5 meters, we did sampling, and then there's a portion that we did that we sampled, and then we got about 63 grams per ton. But this is a narrow reef now. So when we started to blast, thinking that maybe we were just going to get that, we're just going to recover the 63 grams, then it was a poor recovery at the end of the day. But we continued mining because historically there's another shaft that collapsed from that side. So wanted to drive and then hole into that shaft and then maybe do a little bit of prospecting that side again. So we mined this eastern drive to about 20 meters going that side, and then there's nothing. We didn't manage to hole into that old shaft that side. And then coming to the western drive, we also mined. As we mined, we're sampling after every 3 meters in intervals. We did a little bit of sampling, and then there was the grades were actually averaging about 2 grams per ton. Yeah, but now since the shaft is just it was sunk up until 20 meters, the ground conditions is actually weak ground, and there's water down there. So we suspended mining operations here for now up until we start generating more income from the other shafts. Then we're going to come here and equip the shaft and go down further.
This is just on the claims boundary, just coming in. If you're going down the hill there, you end up at the plant site. So we're standing on a banded iron formation ridge, and these rocks have been piled here to make a wall, but they're actually quite interesting, especially this one here, which we'll have a closer look at. So if you come and have a look here, what you can see here are bands of chert and bands of iron oxide. And so, and here it's all disrupted and it's brecciated. In other words, these lumps have been broken off, and you can see the iron oxide running around the brecciated lumps. So it could be this is analogous to the whole of the prospect that we've been looking at, in that this could be the east-west striking zones, and that could be the northwest striking fault coming through, and that structure, that fault coming through, has allowed mineralisation to bleed off either side into the surrounding rocks along the strike of the bedding. So this is quite an interesting piece of rock to have a look at. You can also see there little tiny pits. Those pits are little boxes after pyrite. So that whole area there was full of iron pyrite before it was oxidised. And if we look at some of these other rocks here, we'll also see nice brecciated chert here. And if we look around, we'll also see, probably around the other side, some boxes after pyrite. So this Bandaline formation was heavily mineralised with iron pyrites. So it's all is a good sign for gold mineralisation. That's about it, really.
So the idea is essentially that this might be signals of a parallel strike, more or less, to the strike you're seeing over there between Delta Shaft and Shaft 14.
So assuming these rocks came from this ridge, which probably they did, possibly from over there, it could well be that this is also some mineralisation. And what we actually do see, and you probably saw it on the drone footage, is just down this slope there are some alluvial workings. In other words, the local people have scraped off the soil. It's not very deep here, it's the skeletal soil. It goes fairly quickly into bedrock. And they've picked off gold from the base of the soil profile or from the top of the bedrock. So somewhere from this ridge there is gold being shed down the slope. Now whether it's a significant amount of gold or whether it's a minor amount of gold, we don't know, because we haven't done any prospecting on this ridge apart from geochemistry at the moment. So it's yet another target parallel to the main target that we have to do some exploration on sometime in the future.
What do you think are the kind of the next steps, to be clear? Like, do you need to do more mapping, use more soil, more?
No. At some stage we probably need to do some surface drilling here. Just drill some holes underneath, 1 or 2 scoping holes I would call it, underneath here, just to see what's going on once you get into the fresh rock. So it's a fairly quick money. Just need money to do that sort of thing. And that's it, really. Okay, we're just standing on the Talisman mine now, which is a long strike from Golden Valley. It's actually between Golden Valley, which is to the north here, well, to the northwest here, and the Howe mine to the southeast. And we're on the structure. You can see the structures coming through the valley. And this was an historical mine. It produced, I think there's some of the grades were 40 grams per tonne or so. It was narrow, inconsistent, and it used to pinch and swell, but it was very, very high grade in the oxides. I don't think there's been much sulphide mining done here. So it's quite interesting that it's a long strike from between Golden Valley and the Howe mine. And if we get up on the top of the road here, we might be able to see down through the valley to the Howe mine. Okay, so we're standing right next to the main road from Bulawayo to Howe mine. Howe mine, you can see just in the valley there with the white housing. That's the housing complex and the mine site there. The Slimes Dam is just over the hill, and then the main structure comes up through this valley here into Talisman, where we just stopped a few minutes ago, just down in this valley, and then it runs up through here, through these valleys up to Golden Valley. It's a distance from Golden Valley to Howe mine is about just over 7 kilometres. It's not far. So Howe mine was apparently had a fairly small footprint when they first discovered it. Was owned by a local guy when he sold it, and then as they went down, it opened up and it became quite a wide ore body. And it's now, well, it was recently one of the biggest producers in Zimbabwe. It's done 1 million ounces at about 5 grams per tonne. It's a private company, so there's no published figures on their production at the moment. But if you're going to look for elephants, you want to be in elephant country. So geologists are always the same. Geologists find something and everyone clusters around it. So mines normally come in clusters. So it bodes well. Okay.
Julian Nicholas, part of Carbon Processes, do quite a bit of work with Kavango and the crew. custom elution plant, extraction of gold from carbon, and gold buying agent for the Zim government. On this side, this is all got a lot to do with the mining side. So once the guys have extracted the gold from the sands on the mine using the cyanide process and catching in carbon, they then bring the gold to us, the carbon to us, sorry. From there it goes into the boiler where we run at 120 degrees Celsius, 1.5 bar pressure with a mixture of water and caustic solution, which then allows the gold to be electroplated onto a steel wall. From there, once it's electroplated, it takes roughly about 24 hours for the whole process to happen. We then take the wire wool out of the boxes on the bottom. From there, we head to the other side. Once the guys have got the wire wool out of the boilers, it then comes to this side of the plant. This is where they use nitric acid, caustic soda, nitric acid, sulfuric acid, and ammonium nitrate in order to digest the wire wool, which will then leave us with our end product of the gold, removing all the other metals out of the system. Is the final step. This is once the wire wool has been treated, cyanidation has been done, this is now the final process of the gold. So from here, it'll be mixed with borax. From there it goes into the furnace. There it'll sit at 1138 degrees Celsius for 10 to 15 minutes. Once that's done, the customers will then be finished with the whole process. From there they'll bring it across, sell it to us, and walk out with the cash in hand at the end of the day. There we go, 1.3 kgs.
Okay, so we're back to base here. We've been out in the bush and taking a look at all the projects and got a fairly good sense of the dynamism of Zimbabwe. So I think, Steve, if we speak about the strategy here, it's obviously part of Pambili's strategy to find more projects and build out several camps and add production incrementally over time. So Steve, if you can just explain, we were in the data room previously, just explain how your data set and the information that you have makes it easier to identify projects and some of the challenges that someone else would face if they did not have this type of information.
Sure. Projects come to us in a number of different ways. We've got a reputation here, so people bring us their claims to review and have a look at. We use we obviously plot those up on the geology maps, look through the data sets we've got to see if it's got any potential. Go and have a look at it in the bush, of course. Other ways we do it, we're looking for the mineral systems approach with the different styles of geological targets and focus on areas which we have a look at. We've also got data to look at in some of those areas. And when we go out to the bush, what we're looking for, there's a number of different sort of tick lists, if you like. We're looking for sensible people that don't want stupid amounts of money, thinking they've got a gold mine that's worth millions and millions. We're looking for infrastructure, reasonable roads, electrical supply, and of course, obviously, the geology. We're looking for, we know there's lots of narrow, high-grade zones out there that have been mined in the past, but we're looking for alteration around those zones. We're looking for the potential for dissemination of sulfides and the potential for larger ore bodies. We're also looking to see if they're in production and what scale of production they're in, whether there's shafts there. Some places you go, there are beautiful line concrete shafts that are just not being used, and that obviously gives you an advantage and speeds things up. So it's a whole range of different ways of looking at it.
And if you characterize, I mean, for Pambili, capital is a constraint, obviously. So to make deals then with different vendors, there are, you've mentioned before, kind of 3 or 4 different ways you could do it. Could you just list them and tell
Sure, there's obviously the usual option where you take out an option to purchase it. You might pay a small fee, and you can do your exploration and start work and have a look to see if it's worth what the option fee, the payment's going to be. In this country, there's a thing called a tribute, where you can take out a tribute with the vendor, and you can mine the property. You pay 5% on the tribute, and that gives you a chance to look and see what's there and whether you can mine it at a profit. And then you can also have an option to purchase on that. And you could do an outright purchase if it's a really sensible thing coming at a very low price. Ridiculously, in the past, I've been involved in projects that have bought mines for $5,000 US. I think those days are probably gone, but there are a lot of people in this country that have got problems with school fees and all sorts of things, and they're not mining on their ground at all. So there are various different ways of doing deals.
Yeah, but I mean, if you would take say mine X here and placed in, I don't know, West Africa, it would be 10 times more expensive, or 2 to 10 times probably.
I'm sure.
So it's a big difference because it's cash trapped here. So and that's part of the kind of the overarching opportunity here for you guys, of course. But John, if you kind of characterize what you need, I mean, you want a fairly, to my understanding, you want a fairly short time frame to get into small scale production, and then line of sight to incrementally increase. So can you just put it in your own words what you precisely are looking for?
Yeah. So the good thing about getting early stage production is that it allows you to wash your face. In other words, you can cover the cost of the mine from gold sales. If you're getting back to sort of historic production pre-exploration, that's likely to be less than the potential of the project. But the idea is that we are raising money, as we've mentioned, we are looking to do a raise. The cash that's coming in will be more for the exploration of hitherto unknown extensions of the original ore body, and this is what Steve was referring to, looking for disseminated sulfides and the like. So that's going to give us the upside, the blue sky. Yeah. But in the meantime, we are mining, and we're, as we mentioned before, sort of exploring through mining. So we've been underground, we've seen what's happening there. We're about to start underground drilling, and Steve will give a bit more about this. I'll ask him to explain. But you get a big advantage because you already are underground, and you can then get more bang for your buck when it comes to drilling. So Steve, perhaps you want to just explain a bit about that underground program.
Sure. If you've got access to underground, it's great, because underground drilling, you're in the ore body, you can drill out in both directions. But if you've got a reasonable strike length, you can obviously drill many pierce points through the potential dissemination. So it's an awful lot cheaper to drill from underground than it is to bring in a surface rig. So that gives us an instant advantage. Plus the fact you can obviously map what your workings and sample your workings. So it fast tracks things.
But if you just characterize, I mean, because most of these mines, as you said, shut down between First and Second World War, so the 30s to kind of mid 40s or something like that, and then you had another cohort that shut down maybe in the 80s, and another one in the early 2000s. So at least a couple of decades of not being in production, which means that gold prices were very different, cutoffs were very, very different than they are from now. So if you find a narrow, kind of fairly narrow vein opportunity, there is a shaft, there is some infrastructure, you have line of sight to get down underground and probably find the veins and start mining within 6 to 12 months. It might cost between 200,000 US to $1 million US, something to get that done. What kind of grades would you see? I mean, if you pick out some of the projects you would like, for example, Pambili or something like this, what kind of grades could you see in that situation?
Well, it's a hugely wide range of grades. Some of the mines I've been to, they're mining narrow veins, maybe 50 centimetres, 100 grams per tonne. Some of them are tight, so there's no potential around them, but there are several zones. There might be potential for a sheeted vein system that needs to be drilled. Other places, there are disseminations at sort of 1 gram per tonne. And it all depends what your sort of model is. I mean, a lot of these mines shut down when the gold price was $300 or less, and they had a cut-off grade of, they wouldn't mine anything below 6 grams per tonne. Many of them only went down 100 metres or less, and they exploited the oxides and didn't even touch the sulfides. So there's a huge range, obviously, and a huge amount of potential.
Right. Maybe you can tell as fast as you could two of those stories. Maybe you can mention one mine. Maybe you don't mention the name, but just an example of the mine very high grades at a very low throughput and made a lot of money. And then someone that might have mined 2 to 4 grams somewhere around there, a bit larger scale.
Sure. I think I probably mentioned one the other day. There was a mine to the north of Bulawayo, where the guys mining it back in the late 90s. They drilled a hole and they actually drilled along the vein 100 meters, and it turns out that the vein was a white quartz vein with big blebs of pyrite about like this. Now in the oxides where the pyrite had oxidized out, you could shake the rock and it would rattle, and the rattle would be lumps of gold inside that were remaining from the pyrite. And you could shake it like this and the gold would fall out like salt and pepper on the table. Now that particular family were mining that deposit. They went down 6 levels, hit a fault, didn't bother looking the other side because there were other opportunities with other mines further along, and they just went to the next mine and started mining there instead. They were producing 30 kilos of gold a month with 2 rock drills. They used to have a cage on the back of their dumper to stop people stealing bits of rock out the back of the dumper, and they built the plant in their back garden. So ridiculous. That crazy situation. There are other situations. You've had Clough, were just at the start of the open pit mining. A little bit of open pit mining did start here, and much as you see in Kalgoorlie, if you walk into the super pit, little tiny developments in the sidewalls, and you can see the same thing where Clough were mining open pit down in the Philabuzi belt. So the whole range of deposit types are here.
And then you want to add something?
I was just going to say that if you look at Golden Valley, for example, the historical records which go back, as we were saying earlier, to the mid-1940s, they were mining with 24 kilos, just over 9.5, 9.7 grams per ton. So we're sort of modelling and looking going forward, saying, well, we would expect to get something like 5 grams per ton as a minimum, and that's not unreasonable given the location of the mine. But obviously we won't know until we get some drilling results. That's the sort of target we've been looking at, sort of 5 grams per ton.
Right, and then I mean, in terms of sort of acquisition size, so we can just touch upon that. I mean, from Pambili's point of view, you prefer to do some sort of shared deal or non-cash deal, ideally, because you need your cash to go to Golden Valley or to get the thing into production, because you can't use shares to buy the equipment to get into production. So you need the cash for that, likely. But what kind of sizes are you working with?
Exactly. I mean, as I said before, we sort of aspire to get to 20,000 ounces over the next sort of 3 to 5 years, either through building around Golden Valley and or building around the second hub if we find something useful. And our sort of acquisition targets will be geared towards that. So we have to find something that's going to be able to add to that target within a short space of time. So we don't want to go for something that's going to take a long time to get there. We don't know. I mean, I think we've kind of looking at, Steve, correct me if I'm wrong, I mean, we're probably looking at something that's got a minimum potential of 1 to 2 kilos a month, maybe perhaps 3, without too much capital investment. As we mentioned, we're on the mine. Once you start getting beyond the capacity of the plant that's on site, we really need to know what's underground. So that requires underground drilling, so we can size the plant accordingly. So ultimately, as we start acquiring more projects, then we're going to be sort of capitally constrained to build the plant to process that. But that's what I would call a Hollywood problem, because then we know we've got lots of gold. And then we can deal with that. And once we're at that level, I mean, as you know, Zimbabwe is a mining country. There's lots of suppliers of equipment here, and then we can start looking at debt finance, and some local suppliers might even take equity if they can see the path we're on. So that's on the further down the line. But from the acquisition point, you're right. We don't want to be raising money to pay for projects. And that's why we're looking for projects with near-term cash flow, so that they can support the mine. The mine will wash its face, and any cash we've got is going for this exploration potential that will add the real value in terms of the company's capital, market capital.
If you decide to bring something in before then, or close to that time, you might then decide to to allocate some of that capital to get that into production, if it is warranted. But either way, you're not going to split the attention of the capital to two different places likely. You're going to decide which one you're going to get into production first.
We'll focus on the one that's got the most potential, most near-term potential.
Yeah.
And if, for example, the second project is already producing this kilo a month, then that would be the one to focus on, obviously, because that revenue will fund what we need to do with Golden Valley.
Yes.
So rather than Golden Valley, which is not generating any revenue, you switch around your priorities, but it wouldn't affect our focus, which is to build these hubs, 2 hubs potentially of 10,000 ounces a year.
So Jon, I mean, you have this goal reaching 20,000 ounces in 2 to 3 years from now. That would probably mean, I would assume, at least three separate operations, something like that, depending on how much you can scale them up. But in 1 year from now, where would you like to see the company now, this time next year, so sort of end of August?
Well, I'd like to see that we've got at least one other project under our belt that's producing, and I'd like to see that we've got, we're on the path to that target. In other words, we're making progress towards that target. So either, at that stage, have a resource at Golden Valley and be mining properly at Golden Valley, be mining properly at the second project, and presumably, hopefully have a couple more acquisition targets lined up that we're doing the due diligence on, all heading towards that. I mean, we could be very lucky. We could be, as Steve was mentioning in an earlier example, the next project, even Golden Valley, we might hit one of these bonanza reefs and then we'll have to look for anything else. We'll get our 20,000 ounces from one mine. But let's be realistic. I think we have to have a target, and we're going to keep looking till we get there.
I think it might be worth saying at this point that many of the operating mines here are incredibly inefficient through lack of understanding. So it's actually quite easy in many cases, and doesn't take an awful lot of capital to double the production. I mean, people are doing really silly things.
Yes.
It's no fault of their own. They just don't understand ways of mining efficiently. So,
and that's even on a small scale, very small scale.
Yeah.
And that extends also to the processing. I mean, and I think I mentioned when we were on site, we currently run in Golden Valley on almost a batch basis. All of our leach tanks are batch processes. When we got the gold and the ore that's coming up, and we've got a 24/7 operation, and you go to continuous process, that's when you get your efficiencies in your processing and your production, as well as in mining. And that's, as Steve was saying, you'll get a big uplift in your recoveries just through that.
I can give you an example. I went to a mine some years ago now, and the guy was mining a 1 kilometre long quartz vein at 10 grams per tonne. He was doing very nice. He was very happy. And either side of the quartz vein was a dissemination of arsenopyrite, large crystals, so it probably wasn't a refractory problem. And I picked it up, I said, what about this? And he said, oh no, my dad said that's rubbish, we don't deal with that, we just leave it. And that was running at about 8 to 11 grams per tonne. And they weren't doing anything with it, so.
And why was that? They just made a different host rock, and it just visually was.
They just didn't realise, because historically they'd never used it, so they just thought as I said, his dad said that it's rubbish, don't use it.
So lack of geological knowledge, lack of actual efficient mining and processing knowledge, and also lack of capital. So someone who has all three, you get massive add-on value.
Absolutely, yeah.
And the acquisition terms for all these parties around, it makes sense for all of them. So it's very dynamic. It's exciting for a junior small company to be able to situate yourself here and be part of that. So
yes, and as Steve has mentioned, there haven't been many foreign companies coming in at all, let alone listed companies. And we are getting quite a lot of coverage in the local press, and that's good, because as Steve was mentioning, that we do get a lot of inquiries. Some of them are rubbish, but at least people are coming to us with opportunities. It's coming back to the first mover advantage. It's not only on the projects that we're looking at, but also on people. People are key, and there's a lot of people who are talented and underutilized. Their skills are not being used because they don't know the opportunities, and that early stage or first mover advantage gives us access to those people. So that's another thing that we you shouldn't discount in terms of our approach. Yeah.
For sure, perfect. Okay, guys, so let's wrap it there.
Thank you very much.
Thank you.
balanda tinga tiba